find the absolute maxima of f of x and y, which is equal to 4x plus 6y minus x squared minus y squared on the region bounded by x equal to 0, y x equal to 4, y equal to 0, and y equal to 5. This is the closed and bounded region method, which is equivalent to the closed interval method of calculus of one variable. What you do is first you find the critical points by taking f sub x of x and y, which is going to be equal to 4 minus 2x, f sub y of x and y, which is going to be 6 minus 2y, setting both of them equal to 0, gradient equal to 0 gives you the critical points, gradient equal to 0 vector gives you the critical points, and x equal to 2 and y equal to 3 is the critical point. Now, because we are on this closed and bounded region, let's draw the closed and bounded region. It says y equal to 5, here is 5, x equal to 4, here is 4, x equal to 0, and y equal to x equal to 0, and y equal to 0. So this is the closed and bounded region, and so this point is basically 0 and 5, this point is 4 and 5, this one is 0 and 4 and 0, this one is 0 and 0. And then for each of these, we have to figure out what is the critical point on the each piece. And so here, let's see, piece 1, and piece 2, piece 3, and piece 4. So what are the pieces? Let's say piece 1 is x is equal to 0, and y is between 0 and 5. Piece 2 is y equal to 0 and x is between 0 and 4. Piece 3 is x equal to 4 and y is between 0 and 5. Piece 5 is y equal to 5, x between 0 and 4. Or you can do the other way around. It's less than equal to 4 and equal to 0. That's a good practice for future. Now, one thing I want to do, I want to rewrite a function as a g as a one variable, either g of x or g of y. And then after doing so, I want to find it would be a one variable function, so I can take the derivative and find the critical values in there. So the next thing, it's either g of x or g prime of x or g prime of y. Then I will find the critical values, and then I will have more points to compare, and then I'll find the x and y critical values. So starting here, to make it into a function, see, y is changing, x is constant. Going back into the equation that we had over there, 4x plus 6y minus x squared minus y squared. If I plug in x equal to 0, I get a g of y that is going to be equal to 6y minus y squared. Derivative of that is g prime of y, 6 minus 2y. Critical value for this is going to be y equal to 3. Plugging it back into the and so y equal to 3. What was x? X was 0, so 0 and 3 is a value. Now same thing here. Now I have to set y equal to 0 in that equation, and I get g of x, or you can name it something else. G of x equal to 4x minus x squared. G prime of x is going to be 4 minus 2x, and that is x equal to 2. Y was 0, so 2 and 0. Now in this one, which is 4, 3, and 4. And so in 3, x is equal to 4. Plugging it back into there, I get basically 4 times 4, which is 16, plus 6y minus 4 times 4. 4 to the power 2 minus 16 minus y squared. So I get the same g of y in here as that one. That's then, and so I get y equal to 3, but x was 4 this time, so I get 4 and 3. Now for the last one, y is equal to 5. Plugging it back into here, 4x plus 30 minus x squared minus 25. It gives me g of x is equal to 4x minus x squared plus 5. And then take the derivative. G prime of x is going to be 4 minus 2x. X is equal to 2. And then y was 5. So how many points did I find? This one is within y, is between 0 and 5, so it counts. It's on the first piece. This one, x, is between 0 and 4, counts. Here, x equal to x is equal to 4 and 3. 3 is within the bound, and over here also. So all the points that I found are, let's write it on the next page. Start with the critical point. So I'm going to write 2 and 3, 0 and 3, 2 and 0, 4 and 3, 2 and 5, and then 0, 0, 0, 5, 0 and 0, 0 and 5, and then there are 2 more points, 4 and 0 and 4 and 5. Kind of didn't give myself enough space, but I can 4 and 5. So the next thing that you need to do is go back to this equation and plug in all those points in this equation to see which one is maximum, which one is minimum. It turns out that for f at 0, 0 is going to be 0. At 2 and 0, it's going to be 4. At 0 and 3, it's going to be 9. At 4 and 0, it is going to be 0. At 2 and 3, it's going to be 13. At 4 and 3, it's going to be 9. At 0 and 5, it's going to be 5. At 2 and 5, it's going to be 9. At 4 and 5, it's going to be 5. You have to use a calculator to plug them in, or compute fast. And then among these, the lowest value that you get is 0. So that's the absolute min. Absolute minimum is 0 at 0 and 0 and 4 and 0. Then absolute maximum is 13. Absolute maximum is 13 at point 2 and 3. And